Hi everybody, and welcome to day 2 of chapter 9. Let's go ahead and start with what adjacent arcs mean. So you can go ahead and fill in the definition in your note-taking guide. Two arcs of the same circle sharing a common endpoint. I'll give you a minute to jot this down. When you are finished, let's draw and label two adjacent arcs on circle O. In order to do this, we need a few points on the circle. So let's add point A, C, and K. Remember that adjacent means next to or sharing a common endpoint. So an example would be arc AC and arc CK. Those are two adjacent arcs on circle O. Go ahead and write down the definition for arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of those two arcs added together. So you're going to take AC and add it to CK, and you'll create a big overall arc. To apply the arc addition postulate and to write the statement, you would write the measure of arc AC, make sure you label it properly, plus the measure of arc CK would give you the overall measurement of arc AK. I'll give you a second to write that down. On to intercepted arc. The definition of intercepted arc: it's a portion of the circumference. Remember, circumference means the outside of the circle, located on the inside of the angle whose endpoints lie on the sides of the circle. I'll give you a minute to write that down, and then we'll go along with an example. An example we can draw on circle O. First, we need 3 points. Let's label them P, S, R. Connect them to make the angle. The intercepted arc is the arc that's inside of this angle. So the intersected arc that's associated with this angle would be arc PR. Consider the central angle shown. On the side of the circle, draw an inscribed angle that contains points A and B. Name the vertex of your angle point P. So let's go ahead and put point P somewhere on your circle. Connect it to points A and B to draw an inscribed angle. What do the angles have in common? What does angle AOB, which is a central angle, and APB have in common? Well, they both share an intercepted arc. Arc AB is part of both angles. So we can say angle APB and angle AOB share a common intercepted arc. Use your protractor to measure the central angle and the inscribed angle. How is the measure of the inscribed angle related to the measure of the central angle? So I used my compass, or my protractor, to measure angle APB and I measured it to be 45 degrees. So the measure of angle APB is equal to 45. I took my protractor and measured angle AOB, the central angle, and I got 90 degrees as its measurement. Draw another inscribed angle containing points A and B, and let's name this vertex point T. I'm going to use a different color to represent the other angle. Use your protractor to measure the new inscribed angle that you created with vertex T. After using my protractor, I found that the measure of this angle, angle ATB, was equal to 45 degrees. Let's go ahead and go to the next page. What can you conclude about inscribed angles that have the same intercepted arc? The overall conclusion, if they share an intercepted arc, their inscribed angles are going to be congruent and vice versa. So let's write the inscribed angles that have the same intercepted arc are congruent. There's also something else we can conclude about these angles. This is called the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. I'll give you a second to write that down. If you go back to your other page, you can see that angle AOB was 90, but angle APB was 45. That's where the theorem comes into play. There are 3 different cases on what the inscribed angles could look like. Actually, we are going to include a 4th case. So the first case includes the center O. There's an example of an inscribed angle that includes the center O. Case 2 does not include the center, but essentially goes around it. So there's inscribed angle MPT, but it goes around the center. Last but not least, case 3 doesn't include the center at all. MPT, angle MPT, is an example of an inscribed that does not include the center. Case number 4 is special because it includes a tangent. Do you remember what a tangent is? Go ahead and draw a circle. Let's name our circle O. And let's say you had a line tangent. The point of tangency would be labeled T. And we need an angle, so let's go ahead and draw another line from point T through O. Those are also two examples of inscribed angles. Last but not least, what if we had two parallel lines intersecting a circle? Do parallel lines, remember parallel lines go in the same direction, they have the same slope. If they intersect the circle, are their congruent arcs also the same? So if you take a look at the picture, we have two parallel lines, PA and L looks like R. Are these arcs that are in between them the same measure? This is called the parallel lines congruent arcs theorem. Parallel lines intercept congruent arcs on a circle. So yes, arc PL and arc AR will be the exact same measurement. Voila!